This video is an introduction to the use of radians to measure angles instead of degrees. So up to this point you'd be very familiar with the idea of using degrees with 360 degrees in a circle and 90 degrees as a right angle and so on. But as we get into more advanced trigonometry, it actually makes more sense to use something called radians. So we'll go through what exactly is a radian and how you can convert them between radians and degrees, and a couple of pitfalls to sort of avoid on the way. So the idea of a radian is that if you have a circle and you have, so it's radius r, and you have an arc length here that is also r, then this angle here, theta, is known as 1 radian. So theta is 1 radian when the arc length is equal to the radius. So another way of saying that is if the ratio of arc length to radius, so arc length to radius, when that equals 1, theta, so the angle, is 1 radian. Okay, so what we can say is that theta is arc length over radius, or that leads to the arc length being the radius times theta, where theta is in radians. So that's in radians. So technically radians is unitless because it's a ratio. It doesn't really have a unit. It is just a ratio. Okay, but if you remember that where that arc length is r, so from there to there is equivalent to the radius, then the angle subtended in the middle here is 1 radian. And that's pretty much all there is to radians. So let's have a look at a few examples. So it doesn't matter what the size of the radius is. So we've got a radius of 1 centimetre and an arc length of 1. That means that's going to be 1 radian. We've got a much bigger circle here, radius of 2 centimetres. If the arc length is 2 centimetres, then that's still going to be 1 radian. Okay, radius of 3 centimetres. If the arc length is 3 centimetres, that's still going to be 1 radian. Okay, so it's all about the ratio between the arc length and the radius. So here we've got 1 over 1 equals 1, 2 over 2 equals 1, and 3 over 3 equals 1. So those angles are all the same. Okay, so let's have a look at this one. If we've got a radius of 1 and the arc length equals 2, then theta is the ratio of arc length over radius, which is 2 over 1, which is 2. And you can either use r like that, or you can say 2 radians, okay, or you can just leave it. It is kind of nice to put a little r or something just to indicate that you know that you're talking about radians and not degrees. Okay, so that gives an angle of 2 radians there. So what we want to really sort of think about is, well, how does this apply to our circles? Because it's not always going to be nice ratios of arc length to radius. So we know if we've got a radius of 1 here, or the radius is equal to the arc length there, we've got 1 radian. If this is radius here and the arc length is 2 times that, then we've got 2 radians here. What about for a full circle? Okay, so basically the arc length is the full circumference. So we say L equals the circumference. Now we know that the circumference is 2 times pi times r. Okay, so the angle, theta, which is all the way around here, is going to be the ratio of 2 pi r, the length, over r. Now of course those cancel out. So what we get is 2 pi. Okay, so what we can see there is that in a full circle of 360 degrees, you have 2 pi radians. So full circle is 360 degrees, but it is also 2 pi radians, and that's a sort of fundamental fact that you need to hang on to, because we'll keep returning to that over and over again. Okay, so 360 is 2 pi radians, which means 180 is pi radians. So if we think about this on our unit circle, where we start over here, now we're used to going 0, 90, 180, etc. Okay, so far we've gone 0, 90, 180, 270 in degrees, and then back to 360. Okay, when we're talking about radians, well, we start with 0 again. 0 radians, but then up here we go pi over 2. This is pi, this is 3 pi over 2, and this is 2 pi over here. Okay, so this is in radians. And you need to be able to get used to the idea of using pi and pi on 2 for 180 and 90 and so on. So being able to recognize those values. It's a little bit like exact values of trig ratios. If you can recognize your radian values of the common angles, then that makes your life a little bit easier. Okay, so converting between them is really, really straightforward. If you've got degrees and you're trying to convert into radians, you just multiply by pi on 180. Now pi is quite a small number, it's 3.14. Okay, so 3.14 on 180 is going to be a small number. It's going to make that degree smaller. Okay, so radians, the number that you're going to get from radians is going to be smaller than degrees. Okay, so if you multiply this out and you end up with a number that's bigger than your degrees, then you've probably flipped this up the wrong way. Okay, so that's the way of remembering it. And then obviously to get from degrees, radians to degrees, you go back the other way. So let's just do a couple of examples here. So we're talking about pi on 180. Okay, so the first one, we're going to do 60, and we're going to times by pi on 180. Okay, now we can see that we can cancel these out, and that gives us pi on 3. General rule of thumb, if you can leave it as an exact value using pi, so leave it in terms of pi, then do that. Don't round it. Okay, I'll talk about that a little bit later about why you shouldn't round it. So often we write radians in terms of pi. Now 90 times pi on 180. Okay, cancel that out, gives you pi on 2. Okay, and the last one, 125 times pi on 180. And if you cancel those out, or simplify that down, you end up with 25 pi on 36. And that's generally your convention. So write the number, then pi, and then over whatever it is, and simplify the fraction as much as possible. Okay, so going back the other way, like I said, just flip fraction up the other way. Obviously 180 over 3.14 is a much bigger number. It's going to make this number bigger. Okay, degrees are bigger than radians. So for this example, we've got pi over 8 times, now it's 180 on pi. And generally, if you're doing it, if you've got it in terms of pi, then the pi's are going to cancel out. Okay, and what you get is 45 over 2, or 22.5 for that one. Okay, and for this one, now this is just going to give you some irrational number because you're dividing by pi, but that's okay. It says round to the nearest degree, and if you work that out to the nearest degree, you get 132 degrees. Okay, so much bigger in terms of radians. Now, what I mentioned before about why we leave it in exact values, as you can see, 132 degrees, well, on your unit circle, that's somewhere sort of, where's that, over here. That's quite a big angle. Okay, whereas 2.3 is quite a small number, so although it's the same angle, imagine if you rounded that to the nearest angle, to the nearest whole number, so it went to 2 instead of 2.3, that would make a significant difference. Okay, so really don't round radians at all if you can help it. Either leave it in exact values as a value of pi if you can, or if you can't and you're doing subsequent calculations, make sure you save it in your calculator, or if you must round to sort of 4 or 5 decimal places rather than 2 or 3, otherwise you're going to propagate a fairly major rounding error through your calculations. So just be careful with that. Okay, so that's really all there is to radians. Not as complicated as you might think, but it does take a little bit of a sort of concept shift in the way you think about angles. Like I said, up to this point we're used to using degrees, and we're very happy with degrees and the idea of 180 and 360 and 90 sort of degrees and what those represent. It's a little bit harder to get your head around, pi on 2 in terms of radians, but you will see as we go further into the trigonometry that it gets much easier. The formulae and things are much easier if you're using radians rather than degrees. So, in summary, a radian is the size of the angle of a sector where the arc length is equivalent to the radius. Okay, so the ratio of arc length to radius is 1. So you have this. Oops, forgive my terrible sector. That's radius, and that's also the radius. Okay, it's not an equilateral triangle just because it's all the same length. It's not actually a triangle. Okay, a few people make that mistake. Radians are often measured in terms of pi, so we think about exact values. Make sure you keep that in mind. These are your conversions. You should be able to do these in your sleep with one hand tied behind your back. So get familiar with switching between them. And yes, just be wary that a radian is much bigger angles than a degree. Okay, so don't round too early, or you will end up getting a rounding error and losing marks through a rounding